Hi, let's work through the guided worksheet for week 3, section 1.5 on quadratic equations. This week is a pretty busy week in the class. We've got 3 sections that you'll be working on. The good news, or the bad news, however you want to think about it, is that section 1.5 is the longest section for this week. So after that, 1.6 and 1.7 will be a bit shorter. All right, well, let's get started. So in this section, we're going to be studying quadratic equations, and we're going to start off by looking at 4 methods for solving these types of equations. We're going to talk about factoring, which you should be familiar with from your prerequisite knowledge, the square root property, the quadratic formula, which you should have seen before, and then using your calculator to solve these problems. Quadratic equations, they're equations in which the highest exponent on the variable is 2. That's different than a linear equation where the highest exponent on the variable is 1. We're also going to take a look at something called the discriminant. It's part of the quadratic formula. It'll help us to determine the number and type of solutions of a quadratic equation without actually finding the solutions. Lastly, we're going to take a look at a few application problems. And we'll kind of help you to remember, which you were probably familiar with, is the Pythagorean theorem. All right, let's start off with a definition. A definition of a quadratic equation in the variable x is an equation that can be written in this general form. So it's ax squared plus bx plus c equals 0. We must have a 0 on one side of the equation. It can either be on the left or the right. A, b, and c are real numbers, and a cannot be equal to 0. We say that the degree of a quadratic equation is 2 because it's the highest exponent we see on the variable. Here the exponent is 2, here it's 1. So the highest exponent we see is a 2. We're going to be finding solutions of a quadratic equation. They're also called the zeros of the equation, and sometimes you might hear them as being referred to as the roots, R-O-O-T-S, of the equation. Have you ever seen a banana modeled by a quadratic function? Well, here it is. I found this clip. It's from a program called GeoGebra, which I'll be introducing you to, just as far as a demonstration purposes for illustrating some topics we'll be covering. We're going to talk more about quadratic functions in Chapter 2. I just thought that was kind of humorous. All right, let's look at factoring, something that you're familiar with. So suppose we have a quadratic equation of this form. Notice we've got the 0 on the right side. If it isn't on the right side, perhaps there's a number there. You have to move that number to the other side to get a 0 on one side. What we're going to do is you're going to factor the left side, and then you're going to apply the zero product principle. I'm pretty sure you're familiar with this principle already. Maybe you just haven't heard it, called this. So mathematically, we're going to have two factors that'll be a product on the left side. And consider a and b to be some kind of algebraic expressions equal to 0. It's important that it's equal to 0. This only works if it's equal to 0. Then either a equals 0 or b equals 0. So you're going to apply this principle, and then once you solve a equals 0 and b equals 0 for x, or your variable, then you'll be finished. All right, let's take a look at this first problem, part A. Notice this is not written in the form ax squared plus bx plus c equals 0. So we have to subtract 1 from each side, basically move it to the other side. All right, next you're just going to factor this. Recall with factoring, you need to have, if you're going to multiply the first 2 terms together, they need to be 2x squared. So we know we need an x here in each term and in each factor, and then we need some factors of 2, so it's going to be 2 and 1. Next, we need to look at the factors of -1, so it's either +1 or -1, such that when I multiply the outer terms and I add it to the inner terms, I should get a positive 1x. So that means this has to be a +1 here, and that has to be a -1. So then I'll get 2x times 1, which is 2x, plus -1 times x. All right, so 2x plus a negative x is going to give me a positive 1x, and we're good. Next, this is the zero product rule. Now you just set each of these factors equal to 0. You notice it only works if there's a 0 on this side. we couldn't, just as a side note, we couldn't just factor this part. You notice we could take out an x here and then set one factor equal to 1 and the other factor equal to 0. That's not true. That's not even a true statement. All right, we can only do this part if there's a 0 on one side. All right, once we do that, then we solve those simple equations and we get x equals 1/2 or x equals -1. So those are the solution or the zeros of the equation. Let's try another one. Here we want to solve by factoring. Again, we already have a 0 on one side, so now we can factor. This one's a little bit easier. We notice there's an x in common to both terms, so we just factor out the x, and I'm left with 3x minus 9. Right? Then I set each of these terms equal to 0, so x equal to 0, and then 3x minus 9 equal to 0. And our answers are x equals 0, or when I move the 9 over and divide by 3, I get x equals 3. All right, so we saw for each of these we have two solutions, right? Two real number solutions. All right, that was factoring. Let's take a look at the square root property. So this is really helpful if you have something that's squared just equal to a constant. So perhaps that middle term, that something to the like ax term is missing, this would be useful. All right, what we're going to do is, normally you'd say, okay, if I have this, I'm just going to take the square root of both sides, right? But don't forget that you need a plus and a minus. So when I simplify this and take the square root of both sides, that means u is equal to the square root of d, or u is equal to negative of the square root of d. Notice we have to use the plus or minus of the square root. All right. Now, before you can use this property, you have to make sure just the squared expression is isolated on one side of the equation. You have to get all the numbers on the other side by themselves. All right, and then the square root has to be by itself. Let's take a look at problem 2. Okay, in problem 2, we're starting off with 5x squared plus 45 is equal to 0. We need to isolate the term with the x squared and get it on one side. So I'm going to subtract 45 for both sides, and I'm down to this equation. Divide by 5, I'm going to be left with x squared is equal to -9. Here I'm going to apply the square root property. This tells us that x is equal to positive the square root of -9 or negative the square root of -9. Don't be bothered because there's a -9 under the square root. You know how to handle that. That means that it's an imaginary number or a complex number. So if I simplify each of these, I get x is equal to I root 9. Root 9 is 3, so that's equal to 3i. Or x is equal to the negative of I root 9, which is -3i. So the solutions, remember that another name for that are zeros, are x is equal to plus or minus 3i. I've got a second example here that we're going to look at. Notice in this case, we're just aware of that the squared term is on the left and it's already by itself. We don't have to do any more work. We can't subtract 5 yet from either side because we have to deal with this square. So now we can just directly apply the square root property. So take the square root of both sides, or just think of the inside here. Our u in this case would be x plus 5. So I'm going to have x plus 5 is equal to positive the square root 11, or x plus 5 is equal to the negative of the square root 11. Now I can subtract 5 from both sides. So I get x equals to -5 plus root 11, or x equals to -5 minus root 11. We can write this problem in a bit more compact form with the plus or minus. So it would be x is equal to -5 plus or minus root 11. Whenever you leave a square root or pi or Euler's constant e, which we'll talk about later, in the solution of a problem, that's called the exact form. So when you keep the square root, that's called the exact form, and usually that is the preferred form. Sometimes, though, when we do an application problem, we might need to get the decimal approximation. So make sure that when you can put this in your calculator, right, and you can get these two answers. You should get -1.68 and -8.32. And our convention will be, unless it's otherwise noted for your final answer, to round to 2 decimal places. All right, So we've seen factoring, we've seen the square root property. Now let's go on to the quadratic formula. So the solutions of this quadratic equation, again focusing on having a 0 on one side, are given by what's called the quadratic formula. Make sure you know this formula. You can use this formula to solve any quadratic equation. So, you're going to take a look at some problems in the homework where you're going to decide which method to use. You can actually use the quadratic formula for all of them if you feel comfortable with that. But in some instances, factoring or the square root property might be more efficient and quicker to do. But make sure you memorize this formula. It will not be given to you on an exam. All right, in problem 3, we're going to work on 2 problems using the quadratic formula. We're going to solve this equation, okay, and we're going to give both the exact answers and decimal approximations. Notice the 0 is already on the right side. That's what's important. So if this 1 was moved over here, that would not be the value of C. We have to move that over to determine the value of C. Okay, so first step is to identify the A, B, and C that we're going to need for the quadratic formula here. So A is 2, B is 2, and C is equal to -1. We're going to substitute this into the formula and then simplify it. So we have -b, which is -2, plus or minus b squared. B is just 2. 2 squared minus 4 times a times c, all over 2a. When you put this in your calculator, this should be 4 minus 4 times 2 times -1. You should get a positive 12. And the denominator is a 4. Next, you want to simplify this. Use property of square roots that you know. So square root of 12 is square root of 4 times 3, which is going to be 2 root 3. So we're going to write this as 2 root 3. Okay, next, if we want to simplify this part, you can think of, this is a common denominator, so divide, the 4 goes under the -2 and the 4 goes under the 2 root 3. So it looks like -2 over 4 plus or minus 2 root 3 over 4. Now we can simplify each one of these, and we get the exact solutions. So x is going to be equal to -1/2 plus root 3 over 2, because the 2 goes into the 4 2 times in each case. All right, then if we'd like the decimal approximations, put these in your calculator and make sure you can get these 2 answers. So you notice we see, in this case, there are 2 different real solutions, or real number solutions. Okay, one more problem involving the quadratic formula. Yep, we already have a 0 on one side. We're just going to pick out A is 1, B is -2, and C is 2, and input them in the quadratic formula. So remember, it's minus B, so it's negative of -2, plus or minus. Now, here, make sure you put the -2 in parentheses, because that becomes a positive 4. Right? And then we're going to just simplify this under the radical. I'm going to go on to the next page to skip over part C for a moment. Okay, so simplifying then, we get a -4 under the radical. Remember, our rule from the previous section is square root of -4 is I root 4, which would be 2i. So I replace square root of -4 with 2i, and then I'm going to divide 2 into each of these terms, because they each have the same denominator, and then simplify. So it turns out to be 1 plus or minus I. So for this problem, we got 2 complex number solutions. Or sometimes you'll see them as imaginary solutions. All right, let's go back to problem C. And actually, there are three parts to this problem. Again, picking out A, B, and C, putting them in the quadratic formula. An interesting thing happens in this case. We get a 0 under the square root. We know the square root of 0 is 0. I'm just left with 12 over 6. So in this case, I have x is equal to 2, and we just have one real number solution. So kind of summing up, if I go back for a second, we saw that here, in the first case, we saw it had 2 different real number solutions. Okay, then in problem 3, we had 2 imaginary number solutions, and then in part C, we had 1 real number solution. So just keep that in mind as we're working through the rest of this worksheet. This might be a good place for me to stop, and what I'm going to do is I'm going to go to part 2 of this video. You'll see that in a moment.